Alright guys, here we go with today's lesson. Alright, today's lesson is going to be on representing proportional relationships with equations. Okay, so a quick review of things that we've been talking about in class recently. First one, how do you find the constant of proportionality, which we talked about yesterday. To find the constant of proportionality, guys, you divide to find the unit rate. Remember, unit rate and constant of proportionality are the same thing. So to find that, you're just going to divide your y divided by your x. So your dependent variable divided by your independent variable. And that's going to give you your k, which is the letter we use to represent the constant of proportionality. How do you write an equation for a proportional relationship? Well, you write it as y equals kx. So you plug in that constant proportionality for k. Okay? And then the last thing is, how do you solve and use it? How do we use them? Well, once we figure out what the x or y value is, we can plug them into the equation that we have. That will give us one variable, and then we just use algebra to find the missing variable that we have then. Okay, so I'm going to move on. If you need to pause, go ahead and pause that, but make sure you write down those things. Those are the key notes that you need to make sure that you guys know how to do for what we've been talking about in the last couple of days in class. Okay, I'm going to move on. Alright, example 1 here. Oops. Out just a little bit. Okay. We'll have to scroll down during this one. Example 1. Okay, write an equation that will model the proportional relationship given in each real-world situation. Okay? So let's say there are 3 cans that store 9 tennis balls. Consider the number of balls per can. Okay, so first I want to talk about what independent and dependent variables are. I mentioned that earlier in the video, and I want to go over that. The independent variable, guys, is your controlling variable. Okay, it's the one that we're going to determine that we base it off of. So when we have one of those, you know, that's kind of the controller, and then the other number, our dependent variable, is the one that what part of that one that we have. And sometimes it's not always out of 1. It could be fractions or whatever. We have decimals, but we think of that. So 5 miles per hour, the hours would be our independent variable because the hours is determining how many miles that we drive because it's miles per the hour. So the second part of the per in our unit rate is our independent variable. The first part is our dependent variable. So when we're considering the number of balls per can, our dependent variable is going to be our cans. Okay, so our can. That's going to be independent variable is going to be our can. And the reason our can is going to be independent variable is because that's however many cans we have is going to determine how many tennis balls we have. Since the tennis balls are determined by how many cans we have, the tennis balls are going to be our dependent variables. Okay, so if I think of those two variables right there, the tennis balls are dependent on how many cans that we have. The more cans we have, the more tennis balls we have. Okay, so the tennis balls are dependent on how many cans. Tennis balls dependent, cans independent. They're the ones that's the controller of the two variables. Okay, now let's go on and answer some questions. Find the constant of proportionality. So if I want to find that, we always want to think of our constant of proportionality is our unit rate, which is always going to be y divided by x. And now that we're getting into using variables to talk about these, our unit rate is our y divided by x. So in this case, our y is our tennis ball. That's going to be our dependent variable. So we have 9 tennis balls divided by our independent variable. How many cans do we have? 3. So 9 divided by 3, so our constant of proportionality is 3. Okay, what does that mean? There should be a period right there. What does that mean? That means that we have, 3 tennis balls per can. That is what this means. If I were to write that out as a unit rate, it would be 3 tennis balls per can. Okay, the constant of proportionality, right, is a number of 3. Okay, now, write an equation to represent the relationship. Equation is easy. Okay, remember, we're going to use this format, y equals kx. So I just plug in my constant of proportionality, which is my k. I'm going to plug that in for k. So my equation is y equals 3x. Every equation that we're going to write in this topic that we're talking about, or these lessons here, are going to have 2 variables. Typically y and x, although it is possible on occasion that we would change the y and x with other variables. Okay? So again, let me recap. Our independent variable is our cans, because that's controlling. Our dependent variable is the tennis balls. That is dependent on how many cans that we have. To find the constant of proportionality, we divide our dependent variable by our independent variable. So our y divided by our x, okay? And 9 divided by 3 is 3. So that's our constant of proportionality. When we plug it into our equation, we get y equals 3x, and that is how I get my answer for there. One thing to think about independent and dependent variables, your independent variable is always your x variable. Your dependent variable is always your y variable. Okay, so as we see tables and stuff, we talk about that, that's something to think about. All right? Okay, I'm going to go on to my next slide, so if you need to pause, go ahead. Oops. Okay, in example 2 here. Your mother has accelerated onto the interstate beginning a long road trip, and you notice that the low fuel light is on. Okay? Now, blah, 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 you can read the rest. Here's the key points. There's a half a gallon of tank in the gas when that light comes on. The nearest gas station is 26 miles away. Your mom keeps a log of all the information. Okay? Use it to see if you'll run out of gas. There's some numbers that we can use. So the next of the questions you can answer as we're going through here. Here's our table. I know it's kind of small, but 8 gallons, 224 miles driven, 10 gallons, 280 miles driven, 4 gallons, 112. Okay, what is the independent variable? That is going to be our x variable. When I look at the chart, the gallons is our x, so the gallons is our independent variable. Okay, however many gallons of gas we have in our car is going to determine how many miles we have driven. Okay? Because remember, oops, I forgot the R. There it is. Driven. Miles driven is our dependent variable. Okay? It's miles per gallon. Miles is controlled by how many gallons of gas that we have. So miles is the dependent, our y variable, and gallons is our independent variable, our x variable. Okay, find the constant of proportionality and explain what it means. Well, I'm going to divide y divided by x. So I can use any one of them. And I'm just going to do 224 divided by 8. And when I do 224 divided by 8, I'm going to get 28. What does that mean in this situation? That means that I can get 28 miles per 1 gallon of gas. Okay, 28 miles driven per 1 gallon of gas. That's what my constant proportionality means. It's my unit rate. They're the same thing. Okay, next question. Move on here. Write an equation that will relate to the miles driven and the number of gallons of gas. Okay, we're going to use this. Y equals kx, so I plug in 28 for k. Y equals 28x. There is my equation. And that's it. All right? Now I got to move on to my next slide to finish answering these questions, so if you need to pause, go ahead. Otherwise, I'm going to slide down, and remember that equation. We're going to use it now for our next couple questions. All right, here we go. Y equals 28x. That's what we had. I'm going to erase this here, and then I'm going to real quick cross this out because we don't need that. I'm not going to solve it 2 ways. We're just going to solve it 1 way. Okay. All right, so we have y equals 28x. There's our equation. So, remember the question is we have a half a tank of gas. Can we make it to the next gas station? All right, remember that it was 26 miles to the next gas station, and we have half a tank. Now, some of you are looking at this and like, I can answer this right away, but let's look and see. All right, so do we have enough? So let's use our equation. All right, we could actually use it either way. We could solve this one 2 ways. But I'm just going to plug it in. I have a half a gallon tank of gas. Remember, x is my gallons of gas. If I go back up to my chart, x is my gallons of gas right there. Okay, so I'm going to plug in half a gallon for that. So y equals 28 multiplied by half a gallon. That's going to be y equals 14 miles. What does that mean? That means I can drive 14 miles with what I have left. I need to go 26. Do I have enough gas? No. Okay, why not? I can only, or your mom, her mom, or your mom, she can only drive 14 miles, not 26. Okay, so she will make it. We're going to run out of gas 12 miles short of the gas station. Okay? All right, D, using the equation found in Part B, determine how far your mother can drive travel on 18 gallons of gas. Remember, X is our gallons of gas, so I'm going to plug that in. So here's my formula, or here's my equation. Y equals 28X. I'm going to plug in the gallons of gas for X. So Y equals 28 times 18. When I multiply 28 times 18, I get 504. So Y equals 504. What does that mean? That means your mother can drive 504 miles on 18 gallons of gas. Okay? Just plugging it in, using algebra to find it. What happens if I need to drive a certain amount of miles? How many gallons of gas am I going to need? If I know that I'm going to drive 750 miles, how many gallons of gas do I need here? Okay, well, I'm going to use the same formula. Y equals 28X. This time I'm going to plug 750 in for my Y, because that's how many miles I need to go. So it's going to be 750 equals 28X. Divide both sides by 28. And you get 750 divided by 28. That's going to come out to 26.78. So what does that mean? That means that I need 26.78 gallons of gas in order to drive 750 miles. Okay? That's pretty good if I can drive that far. All right, so that is it for today. So again, our key points of today: you need to know the constant of proportionality is the same as the unit rate. You need to know how to write your equation, which is y equals kx, k being that constant of proportionality. You need to know that an independent variable is your x variable and is the controller, and your dependent variable is your y variable, and that is dependent on what your x is doing. Okay, and then you have to be able to use those equations based on tables or information given in stories, whatever. Okay, that is it for then. So have a wonderful night, and we will see you guys tomorrow.